Good morning! Good morning and good evening and good afternoon. Good day to you, sir. Good day. This should be a pretty interesting live stream, actually, I believe, because the JL Audio 500/1 is an interesting amplifier to repair. I'm just sucking all the solder from the holes while I wait for the stream to pick up a little bit. Please tell me you have a JBL Crown amp there. No, no, no. No, I do not. No. First of all, there's not that many in this country. And second of all, they're very good amplifiers, and so they don't really die. They don't really blow very often. So the chances of me having one of those in the workshop is very, very rare. If I do get one in the workshop, though, I will most certainly do a live stream repair of that amp. Because that's a pretty cool amplifier. I have an XD 700/5. I'm worried about how many JL Audio amps you get. I don't get that many, to be honest. I don't get a huge amount of JL amps. A couple here and there, but nothing like the amount compared to some other brands. The JL Audio amplifiers are generally very, very good. And they shouldn't really die that often. The thing is with JL Audio is that there's quite a lot of these floating around. And so it may seem that I got to get a lot of them for repair, but in reality, there's just quite a lot of them around. So last night's live feed was awesome. Thank you, dude. Cheers. It was pretty interesting, wasn't it? Pretty interesting live stream last night. So right now on this JL Audio, I am just removing all of the dead gate resistors for the power supply. These are 47 ohm gate resistors and they are all shot to bits. So I'm just going ahead and removing all of these, and we're going to load her up with some fresh ones. Once we've done that, I can put some new 3205s in the board and then start work on the output section, and hopefully the output section isn't too badly damaged on this one. Oh, nasty. The trace is damaged for this gate resistor here. Hi, Prince. Whoop, stank. Whoop. Okay, this isn't actually working too well with the hot air gun because the solder's being cooked up, so it's gone super hard. And because the traces are now also damaged because they have got super hot, I'm just pretty much ripping the traces off. So I'm going to take my soldering iron here instead. I'm just going to heat it up so it gets a lot hotter, a lot quicker. And that should get these resistors off without actually damaging the pads. He says, hopefully. Still damages the pads. Yeah, this area is fucked. So we're gonna have to make we're gonna have to do some jumper wires here. I kind of figured out your transistor tester. Go on, man. Let me know what's the deal with it. It is 1:10 in the afternoon over here in the UK. Yours has a label on the bottom saying EVM Electronic Studio. Yeah, it does. EZM Electronic Studio, yeah. Oh my gosh. The fuck? These JL audio amp boards are actually very nice to work on. The board quality, whatever materials they're using for the PCB and the thickness and everything that's going on, they're very nice to work on. The solder melts quickly, it sucks through nicely. The vias always stay intact and nice and strong. Yeah, they're actually very nice amplifiers to work on. Apart from when, of course, the gate resistors explode and burn all the board off. Afternoon, John Paul. How's it going, buddy? I hope your amplifier is still working strong. Have you ever created a homemade amplifier? No. It's one thing to repair an amplifier, but to create an amplifier from scratch is completely different ball game. You need a lot of different skills, a lot of different knowledge, a lot more knowledge, in fact, to create an amplifier from scratch. Repairing is relatively easy compared to designing your own amplifier. With repairing, you're just troubleshooting, replacing parts you find that are bad, but you don't need to necessarily understand the entire workings of the amplifier or why it does certain things. But when you're designing and making your own amplifier, yeah, you need to understand everything. Oh, for fuck's sakes. I hate it when these SMD fucking resistors, they flip themselves over. It drives me nuts. Okay, let's see if I can reconnect those to the pads that broke off then. So if I try and zoom in a bit more, you can see what I mean here. So yeah, you can see there's some resistors that the pads have snapped off on. So what I can either try and do is I can try and use my soldering iron to reconnect it to the pad. It should flow. It should flow and follow the path of heat. So where are we? Over here. Okay, it doesn't seem to want to take and connect the two across the bridge, so what I'm going to do is I'm going to take a small piece of copper wire so that there's something in between the gap for the solder to flow on. So if I do this, like this, a small piece of copper wire, and attach it between the two, then the solder should sit between them. Do you repair radios as well? You need a 2-tip soldering machine. I do have tweezers for soldering like this. So I have these desoldering tweezers, but I don't find that they're very good. They're not particularly useful. Would you consider doing an online training on amp repair? I like watching your vids, but I'm always lost on how you figure things out and what does what. To be perfectly honest, most of my amplifier repair YouTube videos are tutorials in a sense. So if you just watch all my videos, I pretty much go through everything on what to look for, why I'm looking at that section, what parts commonly die, etc. I don't know if I could do any more in-depth tutorials really than my YouTube videos. They're pretty much as much as I can do in terms of tutorial wise. Okay, there we go. So I think, fingers crossed, that's made a good connection on those gate resistors that had broken their pads. The only way to find out is to run some power into the amplifier and have a look at see what the square waves look like on the gates. Yeah, the lead-free solder is absolutely horrific. It's rubbish. Don't bother even trying to use that stuff. Okay, cool. So now that those gate resistors are repaired, let's put some power to the board and just make sure that we have good looking square waves on all of those gate pads before we fit the new 3205s. So we're probing the pin number 1 of the MOSFET pads, which is the gate, and we should see some nice looking square waves present on there on the scope. Ha! On one of the gates we have 5 volts already, which is not what we're looking for. Okay, that's not ideal. So what's going on there then? I'm pretty sure we didn't have that before. Okay. Yeah, that wasn't there before. So before we attach the remotes, we shouldn't have any voltage on the gates. It should be 0 volts. If we've got voltage on the gates, that means that it's going to blow the FET as soon as you apply the wire. Okay, it's disappeared, so it must have just been the teeniest little solder bridge that I couldn't actually see. That's very interesting. So yeah, I before I even put the power on, you saw me go through and check all the solder bridges. Couldn't see any at all. But it turns out that there was one there, because now we have nothing on the gates. So that's ideal. Right, okay, let's turn my attention to this camera. So, we are looking to probe, like I said, the gates here, which is pin number 1, pin number 1, pin number 1, 1, 1, etc. all along the board. And we should see a nice looking square wave on the scope up in the corner of the screen. Okay, so the duty cycle gets bigger and bigger and bigger as time goes on with these things. Still getting bigger until we get to 50% duty cycle. Okay, so we have about a 4.1 or 4.2 volt RMS square wave there. So I'm going to go ahead and compare that to the rest of them here. So that looks the same as that one. That looks the same as that one. Looks the same as that one. And now you see there's a difference here. So if I turn my screen so you guys can see the scope, nice and big. Right, so on this batch here, then the square wave is riding along ground, like it's literally riding dead along ground. However, on this set, the square wave is riding along a bit of DC voltage. See that? So you can see it's not riding along ground, it's riding along some DC voltage, whereas it should be riding pretty much along ground or just underground. So I think that might be the hint of an issue with the pull down transistor. So these square waves are buffered and pulled down by some small transistors on the board here. So if I tilt the board up here, you can see. So we've got Q608, Q609, and Q610 and Q611. These are the 4 drive transistors that buffer that square wave before it gets to the MOSFET pads. I believe that because we have a slight difference there, that these transistors got damaged in one way or another. That would make perfect sense if they did get damaged, because the gate resistors were so badly burnt that the drivers most certainly got damaged to some extent as well. So we need to have a quick look at what these are and make a replacement. So we have some different codes on here. And these are SOT, they're not 23. What package are these? I can't remember. The package code for these. Let me have a quick look at the package for these. So in order to find out what these transistors are, we can read the codes on them. So the codes on them are WY and UY. That's an NPN and a PNP. So all we do is we type in WY SMD transistor into Google. S Manuals is the fantastic website to tell you what's what. And the package that we have is an SOT89. So we are looking at this line here, WY SOT89. So that is a KTA1666. And the other one, the UY, is a KTC 4379. So we are looking for KTA 1666 and a KTC 4379. It's probably not necessary to use the exact same transistors that they have used here. We could probably get away with using some other transistors that are slightly different values, because all they're doing is they're just buffering and pulling down the drive waves. But I don't think I have any within this lower voltage range. All of the SOT89 transistor parts that I have are actually for much higher voltage for the output switching, the output drive switch. So I probably should just go ahead and order some replacements of those from RS Components rather than trying to fit some random ones in the board here. Ah, that's annoying. So that's put me at a stop on this amplifier once again. I was hoping to get this finished today. Oh no, it seems that it's not on here. Ah, that's annoying. So you can't get the original parts. Okay, so what we're going to have to do is we're going to have to look at the data sheet for these and find a suitable replacement. Right, so this is the WY is the PNP, so that's the pull down transistor. This is the one that's most likely to be dead. So this is negative 50 volts, and it's a 2 amp part. And how quick is it? Does it tell me how quick it is at pulling down? Okay, so we have a transition frequency of 120 megahertz. That's pretty fast. The other one is also a 50 volt, 2 amp, SOT89. And this is similar, 120 megahertz. Okay, so what we need to do then is we need to go to RS Components. We need to go to semiconductors, discrete semiconductors. We need to go to transistors, so we need to go to, I think it's bipolar transistors. What is it? I can't remember. Oh, it's a epitaxial planar transistor. So what does that come under? probably just going to be bipolar transistors. Okay, so then we need to take and we need to go to package type so we can select the correct package. This is an SOT89. So scroll down until we get SOT89. There we go. And we are looking for transistor type, NPN and PNP, so that's fine. Let's look for the NPN first. Maximum emitter collector voltage. So yeah, it's a 50 volt part. We could also get away with anything around this range, like 40 volts would be fine, 45 volts would be fine, etc. So let's do that and select some of these. And then maximum DC collector current, it's 2 amp, 3 amp and 4 amp. I'm going to stick with 2 amp because that should speed up, that should make the part a little bit faster, being a lower current part. Alright, let's have a look. So we've got some FCX 690. So these are 45 volt part, 2 watts. And what else do we have? So we only have 3 results here. So we have a 2SCR553. So what's the difference between these two? We've got a 50 volt or a 45 volt. I wonder which one is quicker. Well, these come in a pack of 25. These are cheaper, actually. So let's have a look at the data sheet for these ones. So we're looking for megahertz. So 360 megahertz. So that's actually very fast. That looks like a relatively good part. That's pretty fast. It's got a low output capacitance as well. This has got the turn on and fall times, which the other one doesn't. This one doesn't have on its data sheet, which is kind of annoying. Okay, well at least we can look at that. So turn on time is 45, fall time is 75. So 45 and 75. So let's compare that to the other one here, this Diode Zinc one. Input capacitance is much higher on this one by the looks of things. It's slower by the looks of it as well, 150 megahertz. And we don't have, oh yes we do, we have switching times. On is 33 and off is 1300. So that's probably not ideal. So we are gonna, in that case, go ahead and probably get this one. 2SCR 55 3P. Okay, that looks good to me. So let's add some of these to our basket. And now we're looking for the PNP. So if we remove the transistor type and we now go for transistor type PNP, there's 3 available as well. I reckon we should go with this one, this R-ohm 2SAR, because that is the complementary PNP transistor to the one that we've just added to our basket. Let's just confirm the specifications of this one as well. Yeah, that looks pretty good too. Alright, let's add some of these to basket as well. Holy crap, I've got to buy 50 of these? Ah, jeez. Okay, never mind. So this is going to cost me 12 quid for these. Okay, cool. Let's go ahead and purchase these ones. And then we'll be able to continue with this and prepare when they arrive. Because at the moment I'm not feeling comfortable putting the transistors in because they're not being driven properly. So let's check out securely. Okay, cool. So let's put this amp to one side, come back to it later. I'm actually going to look at the Alpine that we looked at the other day on live stream because my my parts came for it. So we're going to see whether the drive circuit on the Alpine small 4-channel amplifier survived or not. That could be pretty interesting. Here it is. So if you remember from my last live stream, I tried testing some replacement FETs in this board, but they weren't happy. They didn't like those FETs. I think they were too high input capacitance and too high gate charge. So we're going to replace these with the originals and see if the circuit drives them correctly now. This is the 3682s. So we just need 2 of these. How often do you find boards that are too fried to fix? I don't. Usually everything's repairable. The only time when something's not fixable is if it has a programmable IC that is dead, that you can't get anymore. Like for example on Vibe or Orion amplifiers, they have a programmable IC that you can't buy anymore. So they're unrepairable. But generally, the boards aren't really ever too fried to fix. You can always cut the PCB away and make your own new traces. Right, so y'all want to check out this amplifier. This is an Alpine 4-channel, and so yeah, at first glances it doesn't look too complex. So if we have a look at the board at first glance, I mean, yeah, it looks like a relatively complex amplifier, but nothing too crazy here. But then you flip it over and you see that actually it has a whole network of surface mount drive circuits and shit on the bottom. So very complicated, very compressed amplifier here. Alright, so let's see whether replacing the FETs with the original parts makes this thing want to work. Because before it was working, but the FETs were getting stanky hot really quick. And they weren't being driven very happily at all. I think there was too much capacitance because the switching frequency is very fast on this amplifier. So the FETs need to turn on and off very quickly with low capacitance and low gate charge. Otherwise there'll be horrific ringing and all sorts of the capacitance of the gate, and it won't work properly. They'll just get too damn hot. So Yeah, I've cut away a lot of carbonized conductive PCBs before. That's definitely something that you need to do sometimes with car amplifier repair. Yeah, definitely, for sure. Okay, I'm going to let 1.4 amps pass on my power supply here. And get my probe, and we're going to see whether these actually get driven correctly or not now. Because they weren't being driven correctly before. Whew. You can see how damn fast that switch frequency is. That's crazy fast. Okay, so are these heating up and are they being driven correctly? Let's have a look. So we're going to have a look at the drive wave now, and we're going to zoom in a little bit here. Ah, that looks much better. Yeah, that looks identical to the good side. We're drawing 1.7 amps, and they're getting a little bit warm, but not really. Actually, they all run a little bit warm because this is such a fast switching frequency. They will all run a little bit hot. So yeah, fantastic. So that was a nice, easy repair. Just replaced 2 of the FETs on this amplifier, and she's good to go. So that was a really interesting one for you guys to see, that if you use the incorrect parts, the incorrect MOSFETs, then they won't be driven properly, and they will just heat up and explode. I'm just going to wait for the rail voltage to sink down, and on this, actually, no, let's short out the rail caps. I can't be bothered to wait. I'm lazy. Sound digital amps are okay, but they're not the best of Brazilian amps. The best Brazilian amps are Banda. I want to get my hands on some Usina power supplies. If you look on eBay, you'll see that Usina do some crazy mains power supplies, and it always makes me think of that song. Have you seen her? Tell me, have you seen her? Seen her? Oh, oh, why did you have to leave and go away? I've been used to having someone to lean on, and I'm lost, baby, I'm lost. Right, there we go. So the new FETs are installed. I just need to mount this thing back in the heatsink and then test it, and we should be good to go. Hey bro, I was chatting you to the other night during the stream. You suggested changing 50N06 with 30... No. Not 3056. 3205s. So 50N06, replace those with 3205, 3025. Sorry, 3205, 3205. What's going on in the live chat with Exotic Matter? A couple of messages retracted there. Well, I always find it interesting when there's messages retracted. What did you mean to say, my friend? The 666 Blood, how's it going, my friend? Exotic Matter, component suppliers info. What do you mean, buddy? Where do you get your electronic components from? It depends what country you live in. I can't, you know, if you live in the UK, then I can give you a couple of good places to buy electronic components from. But if you live in the US, and it just depends where you live and what the prices are compared to different websites. I live in the UK, so. Evening, Marin-Law. Evening! Ah, it's evening where Marin-Law is at the moment. It's afternoon, just gone lunchtime here. Why does this amp have 4 transformers? Well, it will have... Well, it's got 4 channels, so I reckon this amplifier actually has a transformer per channel. So the best of amplifiers, the best of multiple channel amplifiers will have a dedicated power supply per channel. So I reckon that's what this amplifier's got. It might have a dedicated transformer per channel, perhaps. I'm not too sure. I haven't traced where these transformers go to. Exotic matter. Any alternatives in the UK? Yes, Mercatio. Mercatio is fantastic. RS Components is not generally that expensive, but if you want cheap components in the UK, then you can use this website. Mercatio, very good website, very cheap components. This is where I get most of my bulk components from. The only downside is that you have to be a business. You have to be a registered business in order to use this website. So you have to prove to them that you are a company or you have a business. And once you've proven to them that you're a business, you can then make some orders from them. Sam, thanks for your help today. I hope you'll be on tonight. Yeah, I might be on tonight. We'll see. Do you still have those Sony Explodes? Yes, I do. I have one of the Sony Explodes left. Where do you usually ground your scope probe when measuring gate switching on the secondary side? To be fair, grounding my scope to the amplifier's main power input ground usually works just fine. I don't have any problems doing that. Yeah, sorry, we've moved on now from the 500/1. Let me change this. Just gotta find the plastic plate to this to work out which input is what. Okay, well this amp is fixed. I'm gonna reassemble this later because it's taking too long. Move on to something else just now. There we go. Now check this little bad boy out. This is a Taramps tiny little 250 watt mono amplifier board. Baby little thing. And this had a blown power supply. And so what I did was PS drive. Let's see. What I did is I ordered some. This basically needed a new power supply drive IC. So I ordered some new parts for this. And we're going to fit them and see if it works. Now this doesn't use a TL494 in the power supply. This uses an SG3525AP, which is just another pulse width modulated drive IC chip, basically. It's a little bit more complicated than the TL494. You can do a lot more things with it. As you can see, I've removed the original one, which was here. So I'm just going to go ahead and solder a fresh one on and see if the this thing starts to work. Let's have a look. Well, some blown resistors as well by the looks of things in here. Looks like maybe a blown 47 ohm resistor as well there, perhaps. Okay, well let's start off by just soldering in the new chip and go from there.